Ozone is made from oxygen and an electrical discharge in the air. What happens is that as an electrical discharge, or essentially a spark, is made in the air, it breaks up an oxygen molecule, which is two oxygen atoms, and it splits those apart. And what will then happen is those atoms are unstable and they will combine with other oxygen molecules to form ozone, which is O3. And it is that molecule which is very, very powerful. That molecule is what will break up other hydrocarbons in the air or in the groundwater, and it can also remove odors. At the same time, it can also kill bacteria. And it's an extremely powerful oxidant. In fact, it's one of the most powerful oxidants that exists on the market. Whether it's chlorine or hypochloric acid, ozone is at the top of the chart of all of them, and that's why it's becoming increasingly used as the oxidant of choice.
Ozone is three oxygen atoms bound together. Oxygen as a single atom is very unstable, and it has to find some place to bind to become stable. For instance, the oxygen that the lay public knows is like that we breathe is diatomic. It's two oxygen atoms bound together. That is a very stable molecule, and that's how it occurs in nature. You can force another oxygen atom onto a diatomic oxygen molecule, making three oxygen atoms, but it's very unstable. So that oxygen, that third oxygen atom wants to come off the molecule and then find someplace else to react to become more stable than it is. That is the power behind an oxygen atom. As a matter of fact, oxidation, which pretty much everyone knows is a very powerful tool used in cleaning and sanitizing. Many oxidizers are used for sanitizers. Well, oxidation gets its name from oxygen. Oxygen is one of the most powerful, it's like I said, it's how the name oxidation came about. So if you have a single oxygen atom that will become available to bind with something else, it will. And whatever it binds to will totally change the chemical composition of whatever it bound to. So the way ozone works is you force an oxygen atom onto the molecule using electricity or whatnot, and now it's very unstable. It's looking for a place for that oxygen atom to bind to, come off and bind to something else. When it does bind to that, it changes it. Now, bacterial cells are very organized. They're highly organized. All living cells are. So you disrupt that organization with when you oxidize a part of that cell. Bacteria has cell walls, so the oxygen atom that comes off of ozone hits that cell wall and in a word, destroys. It destroys right there. Now, that can cause a lot of things to occur. It can become leaky, but in general, it disrupts the function of the normal organization of the bacterial cell, and it dies.
When the ozone is done reacting with the compounds either in the air or in the water, it reverts back to oxygen from where it was created. And therefore, you don't have the harmful byproducts that you normally would with other types of chlorine type oxidants.
Once you put chemicals in the water, they're in the water, and they go wherever that water is going to go, down the drain, to a lake, to a river. With ozone, you treat the water, and basically it's just water and oxygen. There's no chemical residual. So there's also the green effect to it.
When chlorine, when there's a bleach type of oxidant that is used, it actually reverts back to chlorine, so you always have something left over, and typically you don't want chlorine remaining after it's done oxidizing, whatever needed to be broken up. With ozone, nothing more is added to the process or the water. Ozone does its work, and it reverts back to oxygen when it's done. As a result, it's a very green solution for a lot of chemical alternatives.
So, so the oxygen atom hits and destroys whatever it hits. It may put a hole in the cell wall, or it may change the conformation of a protein in the cell wall, or one of the glycoproteins or lipoproteins. It destroys it, and it disrupts the function of the bacterial cell. I cannot see, short of something physically, some sort of physical barrier to that, to an oxygen atom hitting it, I cannot see how the bacteria could develop a resistance to it.